Hello, this is Jesse Lukes doing my presentation for philosophy with apologies as I'm doing it while very sick. For this presentation, I have chosen to evaluate the hypothesis quantum mechanics can explain human consciousness via both the standard investigation, i.e., why is it relevant and what evidence exists, as well as the framework laid out in our course text, Philosophy of Science in Chapter 24. Here, W. V. Quine and J. S. Ulian, henceforth Quillian, propose five virtues characteristic of a good hypothesis, which we will explore in detail later. But before we begin evaluating the merits of the question, let us first indulge in some background on the matter. This question is older than you might expect, that is, the actual core philosophical question, which may not be obvious in the hypothesis, which is the question of free will versus determinism. Determinism is the idea that every single event, including a thought, is the result of an unbroken chain of occurrences. In this framework, life is very much like this pool table, or maybe this one, and it makes many people uncomfortable because most of us believe we are acting in accordance with our own free will, and the notion that all future events are predetermined or can only happen the way they are always going to can be unsettling. Now, determinism enjoyed some bolstering from evidence pouring out of the scientific community as a result of the increasing sensitivity of experimental equipment. Enough to where many, including modern professor of biology Robert Sapolsky, have asserted that the evidence is strong enough to rule out free will entirely. So, both proponents of free will and determinism claim the modern science supports their view. How can this be? The long and short of it is that neither view has crossed the finish line. What Penrose and Hameroff suggested is a possible locus of physical activity that may be tied to consciousness at the quantum level, and much of their hopes in the microtubules have been dashed, with the important exception of recent discoveries in anesthesia, which have spurred intense study of the potential relationship therein. Which brings us finally to analyzing the hypothesis, starting with relevance, and to the question of if the hypothesis that quantum mechanics can explain human consciousness, I think we can safely say yes. The following two quotes sum up the relevance nicely. Anesthesia offers a unique and profound opportunity to understand consciousness because it is relatively selective. Many brain activities, e.g., evoked potentials, slower electroencephalography, and autonomic drivers, continue during anesthetics while conscious awareness disappears. Thus, details of anesthetic mechanism may illuminate how the brain specifically produces consciousness and vice versa. And in recent years, Eckenhoff and colleagues have found anesthetic action in microtubules, cytoskeletal polymers of the protein tubulin inside brain neurons. Quantum mobility in microtubules has been proposed to mediate consciousness. Through molecular modeling, we have previously shown olive oil-like nonpolar hydrophobic quantum mobility pathways or channels of tryptophan rings in tubulin, binding of anesthetic gas molecules in these channels, and capabilities for symbol electron resonant energy transfer or exciton hopping among tryptophan aromatic rings in quantum channels. As far as the evidence, so far we only have studies that suggest potential avenues of further investigation, such as the promise of research in anesthetics and neuroscience. The hard problem of consciousness will likely continue to elude us until some drastic leap forward in sensory and imaging tech, allowing us to observe the microcosmos in even greater definition. Until then, we will have to do things like evaluate the strengths of hypotheses, which we will finally again summon Quilliam to help us with. Starting with conservatism, which they define as the number of previous beliefs the hypothesis conflicts with, the lower the better. As prior beliefs about the source and nature of human consciousness are also not substantiated by empirical science, this hypothesis does not conflict with them and gets a pass. In terms of modesty, Quillian state that a hypothesis is modest if it assumes the most humdrum posture, relies on the most expected or normal assumptions. Clearly, this hypothesis is not modest in its claim, except when compared to all other theories of consciousness. That quantum mechanics can explain human consciousness is a hypothesis at all requires a starting point of philosophical wonder on the nature of human thought, which is why this question has largely been put off in laboratory science for so long. Some advancements over the decades have shown a flicker of hope for those wanting to refine theories on consciousness, and so to this, I also give the hypothesis a pass. The virtue of simplicity is the most problematic of the bunch, and Quinn and Ulian knew it, but the example of drawing a line through a graph of plotted points helps solidify the notion. When the hypothesis juts off from a simple curve from the connecting points, it is less simple. Here, the notion that quantum physics can explain human consciousness gets a fail, because determinism would actually seem to be simpler in this context. Now, to generality, the idea that a good hypothesis is generally applicable, which differs from simplicity in the sense that two independent theories may cover more knowledge and therefore be more general, but simplicity will favor one theory if it covers adequately general knowledge. And here, the hypothesis that quantum mechanics can explain human consciousness gets a pass, because the hypothesized notion would only complement what is already known in quantum mechanics and theorized about consciousness. Therefore, information confirming the hypothesis would come from generally applicable science. And finally, the issue of refutability. Described by Quillian this way, some imaginable event, recognizable if it occurred, must suffice to refute the hypothesis. Otherwise, the hypothesis predicts nothing, confirms nothing, and confers on us no earthly good beyond perhaps a mistaken peace of mind. This one depends on the specific quantum mind theory you are criticizing, but I will stay with Penrose and Hameroff's idea that a potential locus of quantum activity within the physical structure of the brain could provide evidence of a non-deterministic reality, at least where it concerns human cognition. It's easy to imagine that future experiments could simply falsify the notion that a Bose-Einstein condensate or microtubule lattice within the brain would somehow link the physical processes of the brain to a quantum process. The falsification would look something like, in fact, no structure in the brain can sustain quantum phenomenon. So this hypothesis gets a pass here as well. So there we have it. Ultimately, the investigation has shown us that further experimentation and study of the possible connections between quantum mechanics and brain function has merit. Thanks, Quillian.